Okay, so lesson 81 is officially solids of revolution 2, washers. So as I said, instead of disc-shaped, there's going to be a hole in the middle. So it's washer-shaped. Notice our formula is slightly different. And let me back up, I guess. What was the volume formula for just regular rotating a solid around an axis or something? Okay, so it's pi times the integral and of the function squared. So whatever made the radius. Notice this time, slightly different, right? It's still pi. There's still squared in there, but it's kind of the idea big R squared minus little r squared. So the bigger radius squared minus the smaller radius squared. And that's the difference. So you're looking, like in this case, the bigger radius squared minus the smaller radius squared. Or when we start looking at the graphs, it will be the function farther from the axis squared minus the function closer to the axis squared. Okay? Keep in mind, these problems can also be done in terms of y still. If you're rotating about the x-axis, it should be done in x. If you're rotating about the y-axis, it should be done in terms of y. So let's look at some of these and see what we can come up with. Example 1. Find the volume of the solid formed by revolving the region between y equals 2x squared and y equals x squared and y equals 4 about the x-axis. Excuse me, about the y-axis. That makes a difference, doesn't it? Okay. So, we're finding volume. Notice it did say about the y-axis. So if this is about the y-axis, when we set this up, we're going to need to be what? Yeah, we're going to need to be in terms of y. And so we'll get that set up here in a moment. As always, I'm going to say draw a picture. Make sure you have the correct visual there. Okay, what do you know about these graphs? Okay, both parabolas. So what's the difference between a y equals 2x squared parabola and a y equals x squared parabola? No, narrow. It's going to be, the one with the 2 is going to be vertically stretched, which means it pulls it up to appear narrower, is what it's going to be. Okay, so I'm basically going to draw, let's see, how can I do this here? A parabola within a parabola. So there's my more skinny parabola. And I'm making this a little bit exaggerated for the purpose of the picture. Okay, that was a little more exaggerated than I meant it to be, but we're going to go with it. So this outside parabola here is, yeah, I really didn't do that the way I wanted it to. Oh well, y equals x squared. The inside one is y equals 2x squared, right? So it said y equals x squared, y equals 2x squared, and what else? Y equals 4. What's y equals 4? A straight line cutting through the y-axis at 4. A horizontal line, I should say. Okay. What is it? So it's the solid formed by these three pieces. Can you visualize that? What is it that's rotating? The piece that is between the two parabolas and below the horizontal line of 4.
This one doesn't have a complete hole.
You're right. This one would not have a complete see-through hole in the middle. At the one end, it would be sealed off. Okay? But because there's a whole other, in part way, we still have to consider it as a washer shape as opposed to a disc shape. Okay, we said we want these in terms of y, yes? So let's go ahead and solve these real quick. If it's x squared equals y, what is that when you solve it? Reverse that though. About x equals, officially it says plus or minus the square root of y. If we talk about plus or minus the square root of y, officially the plus square root of y is in quadrant 1. The minus square root of y is in quadrant 2. But if we're rotating 360 degrees around, do we really need the minus? And so we're not going to need the minus because it's going to rotate all around. And in fact, I could have, I guess, just drawn the quadrant 1 picture because that's really all we need. We don't have to think about quadrant 2. Okay, so we have x equals square root of y. What about if we take 2x squared equals y and we solve that? We first need to divide by 2. X squared is y over 2, and then x is officially plus or minus the square root of y over 2. But if we're just rotating what's in quadrant 1, we're good there. Okay. You ready to set this up? What's first? Pi.
I wish it was that way at home.
Are you referencing dessert?
Yeah.
Okay. It's volume, so I'm going to say an integral. What are the limits on that integral? 0 to 4. Because we are doing this problem in terms of y, my limits are in terms of y. And so that is from 0 to 4. Okay. Big R squared minus little r squared. What's big R squared?
The 1 over 2.
I mean the square root of y over 2. Say what
The
now?
one with the fraction under the radical.
Actually no.
It's not.
I had to stop and think for a moment.
Yeah.
Okay, so, and this is where you want, as we rotate it, the one farthest from where we're rotating around. So what's farthest out from the y-axis? It's y equals x squared, which was x equals square root of y. So this is going to be our big R, and our little r is going to be the one with the fraction. And this is why we draw a picture, right? And so, I'm going to use a bracket to kind of put this all together here. And it's going to be the square root of y quantity squared. So that's big R squared minus square root of y over 2 quantity squared. And then, of course, this is in terms of y, so we're going to say dy. I was trying to be helpful in labeling them as big R and little r. Did anyone catch I labeled them both as big R at first? That doesn't help you, does it? Oh, my goodness. Pick one, you know. Okay. From here, it's doing the math you already know how to do. So pi times the integral from 0 to 4. What's the square root of y squared? What? Oh boy. Square root of y squared is y. Square root of y over 2 squared.
At least 1.
Y over 2.
I mean, if y is at least 3, then y is at least 1 half.
Not going to argue.
It should be at least, it should be exactly.
Okay.
154.
Can I clean this radical or this integral up before I integrate?
You could.
You could. You don't have to. Because what do we have here? This is 1y minus a half y. What's 1y minus a half y? A half y. So you could change this 2 pi times the integral from 0 to 4, 1/2 y dy. Only means you have one thing to integrate, so less chance of messing it up. Okay.
But don't we not want to find a way?
I didn't say you couldn't find a way. Okay, what is the integral of 1/2 y? 1/4 y squared. And I could have asked, what is the integral of y? And that's 1/2 y squared times the other half that's there, which makes it 1/4 y squared, evaluated between 0 and 4. If you want to make life easy on yourself, keep the pi out front and keep the 1/4 out front because those are both constants, right? That's pi over 4 if you want. And then you're just plugging in for y squared, so 4 squared minus 0 squared.
The 0 doesn't matter, and the 4 in the denominator up front will cancel the square.
Okay? Leaving us with
4 pi.
4 pi. Because this is volume, officially I can say 4 pi units cubed. Yeah, 4 squared is 16. 1/4 of 16 is 4, so 4 pi. Or however your brain processes that. So really, I'm kind of reinforcing what you've already done with volume. But now you have to watch out for, is there a hole in the middle, is there not? So always look at your graph when talking volume. You ready for example 2?
Yeah.
Well, ready or not, here we go then. How's that? I'm sensing some, you guys are over this, ready for the weekend.
A little bit. Yeah, I do that.
Not necessarily over this specifically, just over school today.
I could use my 8 maths from it. It's been a long week. We've had a calc test and a physics test this week.
And we've had a full 5 days of school. That's, you know.
That's probably the worst one.
I'm just
And
thinking
if
for-
it's a
This is our
physics
first
test,
full week of school in February.
Probably a retest.
Is it really?
The first, I went back and looked, based on a conversation we had at lunch yesterday. The first 3 weeks of the semester, which should have all been in January, were all normal weeks as a school. And then since then, we haven't had a normal week.
That's pretty cool.
Now, I will say our classes have only had one normal week because in the second week of January is when Natalie's quarantine hit, and I missed 3 days over 2 weeks. So I haven't had a normal week since the first week in January. It has been. Okay, example 2. Side note, right? Find the volume of the solid formed by revolving about the what? Y-axis. We're going to practice Y-axis again. The region bounded by y equals x, x equals 4, and the x-axis. Got that shape figured out? I'm only going to draw first quadrant. That's all we'll need.
Don't want to get just a triangle.
Sounds like a triangle.
Feels like a triangle. Smells like a triangle. Tastes like a triangle?
I'm about to find out.
Wow. Okay. Y equals x. What's the line y equals x? Diagonal line, right?
It's like a triangle.
Goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Okay, what's the line x equals 4? Vertical line at 4. Okay. And the x-axis. So it is indeed a triangle.
There we go.
I like solving this equation for a while.
Okay. It's indeed a triangle. And notice it was about the y-axis. So again, we're going to say that everything needs to be in terms of y. Well, what are the equations we have?
X equals Y.
Okay, x equals y. Well, it doesn't matter, x or y, right? And the other one was x equals 4. Well, there is no y, so that's like saying x equals 4 plus 0y. So we're good. We're in terms of y. No craziness here. Okay. There's one thing we haven't talked about. Well, I guess we'll talk about it here as we set it up. I'm going to say v equals, what am I going to start with? It's volume, so pi. Thank you. The integral. What are your thoughts here?
Need to find the intersect point.
Yeah. We officially need this in terms of y, right? So we need to know, we obviously know the 0 down here, but we need to know what is that point right there. Yeah. Because it's y equals x, it's on 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. And so, what values are we going to use? 0 to 4. Okay? Now, remember, we're going around the y-axis. So, squared minus little squared.
There is no wrong.
Well, as we rotate this triangle, okay, as we rotate the triangle, it's going to go around the y-axis, right? Can you visualize this?
Okay.
It's going around the y-axis. What shape are you seeing?
Funnel.
Okay. Maybe a bowl with slanted sides. I can see the funnel idea. We just won't have a hole in the middle again, right?
Yeah.
Okay. Okay. So what's our outside curve? What borders? X equals 4. And so x equals 4, what do I use right here? 4. Because we're doing volume, it's r squared. So we're going to use 4 squared. So yes, it's a constant, but that's what the equation is.
They don't have to be in Y.
It's in y as long as it's x equals.
Oh. Okay, yeah, no.
Okay? There is no y in that particular problem, but to be in terms of y, it just has to say x equals. Okay? So 4 squared, what's making the inside of this shape? The x equals y, and so we're going to go 4 squared minus y squared. dy. Now, I think this problem is easier to integrate than the last problem. So pi times the integral from 0 to 4. 4 squared is 16. So I'm going to be integrating 16 minus y squared. What is the integral of 16? 16y minus the integral of y squared.
-1/3
y cubed, evaluated from 0 to 4. So pi times 16 times 4 minus 1/3 of 4 cubed. And then minus, what about when you plug in zeros? That part just ends up being 0 minus 0. Okay, do some math. 16 times 4 is 64. What's 4 cubed? 64, right? Because that's what 16 times 4 was. So, I'm going to say pi times 64 minus 64 thirds.
1/20.
Okay. This is a good practice without a calculator. To get a common denominator, we need a denominator of 3, right? And so 64 times 3 is 192 thirds minus 64 thirds, which is where Daryl gets 128 thirds. So 128, and you can write it as 128 thirds pi units cubed, or 128 pi over 3 units cubed. Is that the same pencil?
Yeah, it just kind of stopped working, so I'm using a pen instead.
Do you need to borrow a pencil?
No.
Okay.
Just trying to
Just threw mine back and forth.
That's a good idea.
Does it have lead in it?
I guess not.
Okay.
I hope Bella didn't realize this, or
Example 3. Find the volume of the solid formed by revolving the region between y equals x squared and y equals square root of x about the x-axis. Okay. A picture. True. A picture for visual effects. Just because we're going to need to know big R versus little r, right? So, what's the graph of y equals square root of x look like?
I just did it.
Okay, top half of a sideways parabola, which means it's only in quadrant 1, which is why I did that one first. Because what's y equals x squared? A normal parabola, but we're only going to need to worry about that parabola in quadrant 1. So there is y equals x squared. There is y equals square root of x. I'm waiting for the descriptive words for this shape. Okay. Feather? Okay, well, whatever that shape is, we're going to be revolving it where? Around the x-axis this time. Made Daryl happier, at least in that case. What are we going to need to know when we go to set this up? Yeah, our boundaries. That intersection point. Think about, pick one of the graphs and think about what points you would use to draw that. So like if you think about y equals x squared, we start with 0, 0, then what? 1, 1, 2, 4, so on and so forth, right? Y equals square root of x. Which one matches up? You guys are thinking way too hard.
I want to say 1, 1, but I don't think it's
Yeah,
really.
it is. Because 1 squared is 1, and the square root of 1 is 1.
So we have to skip one step forward.
Okay, so volume is, what do I start with? Pi times integral from 0 to 1, these are x values this time, of big R squared minus little r squared. Square root of x squared, because that's the top graph, minus x squared squared. It's a mouthful, but it's not bad. So pi times the integral from 0 to 1 Square root of x squared is x minus x squared squared, x to the fourth, dx. Pi times, what's the integral of x? 1/2 x squared minus the integral of x to the fourth. Yes. Evaluated from 0 to 1. Okay. So, have you done the math? 1/2 times 1 squared minus 1/5 times 1 to the 5th. And then minus 1/2 0 squared minus 1/5 0 to the 5th. So really we just have to know 1/2 minus 1/5. Common denominator says tenths. 5/10 minus 2/10 is 3/10 pi. So 3 pi over 10 units cubed. Did that one go better since we were able to stay in x?
Subtracting the fractions, that was pretty intense.
Okay, the fractions on the last one were more intense than the fractions on this one.
But these ones were intense.
I didn't get it until Logan says he gets it. And I'm like, what's there to get? Okay. One more. The region between the graphs y equals x squared plus 2 and y equals 1/2 x on the interval 0 to 1 is revolved about the x-axis. Find the volume of the solid of revolution generated.
So this one might be suspended.
Okay.
It's like Nathan.
Y equals x squared plus 2. What is y equals x squared plus 2? Parabola that's gone up a bit. I'm going to go with a parabola that's gone up 2 units, but okay.
It's the same thing.
What does a y equals 1/2 x plus 1 look like?
It crosses
It's a
the
straight line that's gone up one and has a slightly different slope.
You had to think about that.
It intersects the y-axis at 1 and then has a slope of 1/2.
Okay, so intersects the y-axis at 1, slope of 1/2, so up 1 over 2. Okay. And then what else did it say? On the interval? 0 to 1. Because otherwise, if they don't give us an interval here, what are we doing? Like, there's no boundaries. So on the interval, 0 to 1. And so we have this little shape here. And which axis are we revolving around? The x-axis. If we were just revolving around the y-axis, it would actually be easier in this case. Okay. V equals pi times the integral from 0 to 1, we're in terms of x's, of x squared plus 2 quantity squared is my big R squared
minus 1/2 x plus 1
minus 1/2 x plus 1 quantity squared. So this would be a good one if we could just stop here and just write the equation. That would be awesome.
I need your button to the calculator.
Okay, so for practice purposes, yes, you need to be foiling, yes? X squared plus 2, when I foil that. Okay, x to the fourth plus 4x squared plus 4. I'm going to leave these in parentheses because we're now minusing this whole next piece. So if you go ahead and write it without parentheses, minus carefully.
I can't even get it right.
1/2 x times 1/2 x is 1/4 x squared. 1/2 x times 1 and another 1/2 x times 1 is just 1x plus 1 times 1 is 1. Pi times the integral from 0 to 1. I would definitely encourage a cleanup step. X to the fourth is going to stay x to the fourth. 4x squared can go with, we can subtract 1/4 x squared. So 4 minus a fourth. 15/4. So I was just going to say, if you make 4 a fraction, it's 4 over 1, becomes 16 over 4. 16 over 4 minus 1 over 4 is 15/4 x squared. If we're going to go in order, we also need to subtract then x. So minus x. And 4 minus 1 is plus 3. So I have in my integral x to the fourth plus 15x to the 15/4 x squared minus x plus 3. The good news is when we integrate this, we're only evaluating from 1 to 0. That's the good news, right? Keep carrying that pi down so you don't forget about it. Okay, integral of x to the fourth. 1/5 x to the fifth. Integral of 15x to the fourth. 15 over 12 x to the third. If you want, 15 over 12 would reduce to what? 5/4 x to the third minus the integral of x. One half x squared plus the integral of 3x. Evaluate between 0 and 1. Again, good news. 0 and 1.
Let's just write dx after that instead of what it's from.
Okay. We plug them in. We plug in 1/5 plus 5/4 minus 1/2 plus 3. You need to at least process, is the other part going to matter? But when you put in 0 for all of them, it's not going to matter. What would be a common denominator here? 5, 4, and 2 all go into 20. So make everybody 20. 1/5 multiplied by 4, 4/20. 5/4 multiplied by 5, 25/20. 1/2 is 10/20, and 3 is going to be 60/20. Can you add and subtract those numbers with your mental math? Notice I did mine quietly, and I thought I'll just write it down and see if you guys agree. should have gotten 79/20ths pi. Or 79 pi over 20 units cubed.
Not awake today.
I was thinking maybe with synthetic, like you would have to do the corrections in physics.
Oh, that would have been smart. I mean, they help you if there's
Yeah, maybe a grade. Hang on.
Yeah, I usually get like 3 points.
I think last time they raised my grade by 0.8.